Hello and welcome to my tutorial on scalars and vectors. So, what are scalar and vector quantities? Scalars have no direction, they're just an amount of something like the mass of this flower here. Or it can be the temperature of water, say, in a cup. And it could also be time, length, speed, or energy. Vector quantities have a size or magnitude and direction. So the weight of this bag of flour is a vector quantity, as it's the mass times the gravitational field strength, which is pulling it towards the gravitational field. And you can add vectors using Pythagoras and trigonometry. So we'll have a look at this example. We need to find the hypotenuse for this particular one. So it's as simple as writing an equation: r squared equals the sum of the two squares and then square rooting it to make 5 meters, and then doing a bit of trigonometry, knowing that you need to use the tan inverse to find the angle theta, and that angle would be 33.1. So it would be this angle here. This would be theta. And so the vectors are always drawn tip to tail, and then from the tail of the first vector to the tip of the last vector to give the resultant force. So this is what's known as the resultant vector. And you can use Pythagoras because it's always at right angles. If there is an angle other than 90 degrees stated here, it will always be stated, and that means you just cannot use the Pythagoras method. You need to use another method. But for now we're going to use Pythagoras because it's a lot easier to start off with. So now we use the same method for resultant forces or velocities. So velocity has a speed and direction. So if we look here, 90 degrees for this particular one as well. 2 newtons and 2 newtons in both directions. So then you do the sum of the squares, which is 8. Square root of 8 is 2.83 roughly. And at 45 degrees, because the force is equally shared, it's an equally shared resultant force. This is a way of adding the vectors tip to tail. So I'll just put adding vectors. And yeah, that's one way of drawing the problem. And looking at the next example for this velocities, we have 14 ms minus 1 and 8 ms minus 1 in the other direction. Going from tip to tail again, we have the angle theta here, right angles, and the resultant being there. So then we take the sum of the two squares here, square root it, and we get, so root 260 is 16.1 ms minus 1. And then to find the angle, you need to use the tan opposite over adjacent, so 8 over 14 equals 0.5714. So then theta will equal 2.97 if you do the tan inverse of 0.5714. So now we move on to scalars and vectors. So we're going to split vectors now into their horizontal and vertical components. So the two formulae you need to remember for deriving this, if you look at our deriving diagram of science, we have cos theta equaling Vx over V, with V being the x direction at the x direction, velocity in the x direction, and the velocity resultant one here. We can then rearrange it to make v cos theta, likewise for the y direction as well. So the two formula you need to remember is Vx equals v cos theta and Vy equals v sine theta. So looking at a quick example now, we have one velocity at 4.33 ms minus 1 and another velocity at 2.5, resultant at 5 and the angle at 60. This is the angle of the resultant velocity. So the two components can be split into 5 cos 60 equaling 2.5 ms minus 1 and 5 sine 60 equaling 4.33 ms minus 1. So you use the resultant velocity plus the sine or cos of the resultant velocity's angle, and then you get the different velocities. So moving on now to some practice questions. So if you look at this question, the wind is creating a horizontal force of 20 newtons on a falling rock of weight 75 newtons. Find the angle of the resultant. And a glider is travelling 20 meters per second at an angle of 15 degrees below the horizontal. Find the horizontal and the vertical components. So I'll let you have a go, and if you're stuck, come back and have a look at the answers. So having a quick look at the answers now, we have our 20 newtons force and our 75 newton force. But since the 75 newton weight is going down, I'll just redraw this triangle to have it the other way up. So there's our weight force, there's our horizontal force, and the resultant is the hypotenuse of the triangle. So I'll put the R, 20 here, and the 75 newton weight here. So you do the Pythag, take the squares of 20 and 75 and add them together, making 6025. Taking the square root of that, and that makes 77.6 newtons. And this is tan theta. So theta is this angle here. And I'll now write theta and theta there and there. Ignore what I wrote on the right hand side. So tan theta is 20 over 75, and that makes 0.267. Theta would, by doing a tan inverse, you would get theta making 14.9 degrees. So theta would be 14.9 degrees. And so you just put 7.6 newtons at 14.9 degrees south. That'll be south westerly. So put south. West direction is not necessarily important. If you get it wrong, you just need to summarize what you found out in your two calculations and make it clear to the examiner as a final line sort of thing at the end of a question. So now we'll move on to part 2. 15 degrees at the horizontal with VH and the velocity there. So to work out VH, we would do 20 cos 15 to equal 19.3 ms minus 1. That's 1 mark. And for the vertical velocity, it will be 20 sine 15, which is 5.2 ms minus 1. And that's all you need to do. A well-labelled diagram like that and your two calculations written out clearly would give you the 2 marks. So that's it for this tutorial. I hope you found this useful. Please like, comment or subscribe or whatever you want to do, and see you next time.